So this is the hardest part. Okay, if you to ask me about this method, this is the what? Okay, must determine the function first. After you have determined the function, all you need to do is do dy by dt. So this is equal to L cos t d theta by dt. Okay. So this is your equation number 1. And note, we are also aware that d theta over dt is also equal to your omega. So from here, you rewrite equation number 1. You have L cos theta omega. Okay, or if I were to read, it's quite dangerous to write things like this. You write this as L omega cos theta. Okay. So this correspond to our what? Our VAB. Okay. Right? Because what did I say? Right? What did I mention to you? So C, point C is a link to what? Is to link to AB. So i.e., what we realized is this, okay? What we realized is this. Points, therefore, when this is specified, sorry, I missed this out. Point A, B, and C are part of a what? Rigid body. Okay. Then from here, we can do d squared y over dt squared. Before we do that, we also have to take note that L, again, is a constant. Right? L is a constant, and omega and theta, right, is a function of time. Okay, it's a function of time. So from here, we have what? We will have L cos theta d omega over dt plus, or not plus, we have to incorporate a minus, L omega sine theta, and we have d theta over dt. So this corresponds to our equation number 2. Right? So now when we recall, note that d omega over dt is equal to alpha, right? And this happened to be equal to 0 because of what? Given to us constant angular velocity, right? That's given in the question. And we are also aware that d theta over dt is equal to omega, right? So therefore, d squared ri over dt squared will be equal to minus L omega sine theta, and then we multiply by omega again. So this will in turn equal to minus L omega squared sine theta. So this will be equal to your AB. Okay. So what you realize over here, right? Both this value over here and this value over here, right? They are all for the what? Y direction only. Likewise, this is also for your Y direction only. And why is it only for your Y direction only? When you see diagrams like that, right? This slider, did they call it a slider? The guides, right? And it specifies the guides only move in the what? Vertical direction only. We clear? Okay, so when to use this method is only for what? One direction. Are we clear? Absolute motion only. Okay. Easy, right? Right? Am I right or wrong? The thing to formulate, okay, is you need to visualize this part. So this is what we call analysis. And not a lot of courses need you to do analysis at this young stage of engineering, but you're doing it now, which is important. Okay, that makes you different. The only way to be able to be comfortable with analysis is the more you do, the more comfortable you will be. Unfortunately, hard work does pay, okay? Don't let ChatGPT do all the work. Are we clear? I love ChatGPT, but anyway. Example number 2. So if we look at example number 2 now, right? It's not exactly the same, but the foundation is very similar. And I could not solve this problem without this information, okay? So again is, you will see this structure over here, right? So the circular arm cam of radius r is rotating clockwise. It's specified it's rotating clockwise over here, okay? About pin O, right? Which is at an eccentric distance E from the center of the cam. So we are going to determine the velocity and acceleration of the rod as a function of theta. So this is another case that is ideal to use this method because the motion is in one direction only. Right? Motion is in what? Okay, the motion is in x direction only. Okay. Now, before I go any further, I want to highlight for this case, right, the one that we have before. Are you all comfortable? No doubt the omega is constant, the angular velocity is, the angular acceleration is constant, but you will still have an angular acceleration at arm AB. Are you okay with that? This is because of the what? when you are at 90 degrees to 45 degrees, and then from 45 to 0 degrees, right, the change in distance is smaller. What do I mean by that? Right? So if we look at a semicircle, or a circle, right? If I were to sketch a, if I were to sketch a 45, let me do this properly. If I were just to divide this by 45 degrees, I'm just going to sketch 45 degrees, okay? Let's hope I do it right. Right? You can see the distance between here and here. So I call this U1, and the distance from here and here is our what? U2. And we know that U2 is greater than what? U1. For this reason, no doubt that omega is what? Omega is what? Constant, right? Your acceleration, right? Because of this effect, your acceleration is not constant. Okay, your vertical. So your vertical acceleration is not constant. Okay, because I've been teaching this too many times, student will ask me why, when this is a fact, okay, we still have acceleration about AB, and I don't want to enforce that this is math, okay, there are physics reason behind it. Coming back to here now, okay, so we have to determine the motion in the x direction only. So this is our x and this is our y, okay. If this problem is without this diagram over here, okay, I'll be lost. I'll be really honest with you, okay. So over there, what is given to us is tend to what? Help us. Okay? Tend to help us to do what? Okay. So we know over here, this is our point O. Okay. And given to us that the distance from here to here, this distance is our E. Right? And then furthermore, we are also given that we have a distance from here to here. This distance is R. And we know that this angle is equal to theta. And we are provided the information that this thing is coming down in omega. So what we want to relate now is we want to find, right, from O to here to the end of R over here, and I'm going to call this my X at point A, because over here is my A. So what we know that is constant is R over here is a what? Constant, right? So the first thing we have to determine down here is what is our constant, okay? Right, and then from here, right, we know that the wheel is a what? It's a rigid body. Okay, we are aware that the wheel is a rigid body.